doing well. Welcome to another video of this module, Physical Layer of OSI Model. My name is Sanjeev, and in this video we are going to discuss about that how the communication is happening using the physical layer. So let's just start with the data communication. So physical layer in your OSI model plays the role of interacting with the actual hardware and signaling mechanism. So physical layer is the only layer in your OSI network model which actually deals with the physical connectivity of two different stations. It is the lowest layer of your network, and this layer actually defines the hardware equipment, cabling, wiring, frequencies, pulses that are used to represent the binary signals, etc. So actually, physical layer provides its services to data link layer. Data link layer hands over the frames to physical layer, and physical layer converts them to electrical pulses which represents the binary data. That binary data is then sent over the wired and wireless media. So here we have talked about sending the binary data. So how that is being sent? Let's just see. So when data is sent over the physical medium, it needs to be first converted to electromagnetic signals. So data itself can be analog as a human voice or digital such as a file on the disk. So it can be of any type, analog or digital. Now both analog and digital data can be represented in digital or analog signals. So here we have two kind of signals, as you know, digital and analog signals. So before discussing more about your digital and analog signals, let's firstly see how we represent your digital as well as the analog signals. So here, if I have to write the digital signal, I would represent it as like this. So here, this represents 1 and this represents 0. Okay. So your digital signal is basically representing 1 or 0, that are your binary bits. If I have to represent the analog signal, then we can draw your analog signals like this. Okay. So analog signals are generally represented in the waveform, while your digital signals are represented like this in binary form as 1 or 0. Now let's learn more about them. So your digital signals are discrete in nature and represent the sequence of your voltage pulses as we have just seen. So digital signals are used within the circuitry of a computer system, while your analog signals are in continuous waveform in nature and are represented by continuous electromagnetic waves. So as you know, the computer can only understand the binary language, that is in the form of 0 or 1, and also stores the information in the digital form. So thus we need to convert data into digital form so that it can be understood by your computer. Now there are some conversion methods that are used for your data transmission. So these methods are your digital to digital conversion, analog to digital conversion, digital to analog conversion, and analog to analog conversion. So let's firstly discuss about your digital to digital conversion. So digital to digital conversion signifies the converting of digital data into digital signals. It can be done in two ways, either using the line coding or block coding. So for all the communications, your line coding is necessary while block coding is optional. What this line coding is? So line coding is the process of converting your digital data into digital signal. This is said to be line coding. Digital data is found in binary format. It is represented, or you can say stored internally as a series of ones and zeros. So digital signal is denoted by discrete signals which represents your digital data. So basically, if you are getting your data something like this, let's say 1, 0, 0, 1, 1, 0. So how you will represent its digital signal? So it would be something like 1, then 0, then next is 0, then after that it is 1, then 1, and then it is 0. So this is how your binary data is represented in the form of a digital signal. So this digital data here of 1 and 0 series is represented here as a digital signal, right? So now in line coding also, to convert your digital data to a digital signal, there are three types of line coding schemes available. One is your unipolar encoding, another one is polar encoding, and third one is your bipolar encoding. Now what happens in your unipolar encoding? So unipolar encoding schemes use signal voltage level to represent your data. In this case, to represent binary 1, high voltage is transmitted, and to represent 0, no voltage is transmitted. So that's why it is also called as unipolar non-return to 0, because there is no rest condition, that is it either represents 1 or 0. So if you have to represent your data in the terms of unipolar encoding, so if you have the data something like 101011, okay, so you will represent it as like this. So here this is your 1. For 0 you won't do anything. This is 1, then this is 0, then this is 1, and next is also 1. So here it is. So this is how you represent your digital data in the form of digital signal in your unipolar encoding. So there is no rest condition. We are just showing high voltage for 1 and nothing for 0. So there is no rest condition here, right? So basically for high voltage, this is your amplitude for voltage and this is your time taken. Now let's see the another kind of encoding, that is your polar encoding. So polar encoding is another type of line encoding. So your polar encoding schemes uses multiple voltage levels to represent your binary values. So we represent your polar encoding as I have earlier shown you. Here we were representing this as 1, your trough, and crust as 0, right? So this is your polar encoding. This is how we represent your digital data in the form of digital signal in polar encoding, right? Now further actually your polar encoding also have 4 types. One is your polar non-return to 0 encoding, further return to 0 encoding, Manchester encoding, and differential Manchester encoding, right? Now third type of your line encoding is bipolar encoding. So bipolar encoding uses 3 voltage levels, positive, negative, and 0. 0 voltage represents binary 0 and bit 1 represents by alternating positive and negative voltages, and bit 1 is represented by alternating positive and negative voltages. So for example, if I have to draw, if we are representing the data 1011001001 in the form of bipolar encoding, then it would be represented as, here it is 1, this is 0. Now for this particular one, we will alternate it to the negative part. Then for this one, we will again alternate it for the positive part. Then this is 0, 0. Then for this one, as last one was positive, so this one would be represented by a negative voltage. Now this is 0 here. So last one was represented by negative, so this one would be represented by positive. So here you have 3 levels, negative, positive, and 0, right? Where your bit 1 is represented by alternating the positive and negative voltages. So this is your time and this is your voltages amplitude, right? So these were your 3 types of line encoding: unipolar, polar, and bipolar. Now, if we will talk about your block encoding, so to ensure the accuracy of the received data frame, redundant bits are used. For example, in even parity, one parity bit is added to make the count of ones in the frame even. This way, the original number of bits is increased and it is called as the block encoding. So, block encoding is represented by slash notations generally, which means you can represent it as like this. m bits slash n bits, where this represents that m bits here are substituted by n bits, where n is always greater than m, right? So after your block coding is done, then further it is line encoded for the transmission. Now this was all about your digital to digital conversion. Now let's come to the another conversion, that is analog to digital conversion. So as you know, microphones create analog voice and camera creates analog videos, which are represented in analog data. To transmit this analog data over the digital signals, we need analog to digital conversion. Analog data is continuous stream of data in the waveform, whereas digital data is discrete. So to convert analog wave to digital wave, we use the pulse code modulation, and PCM is actually one of the commonly used method to convert analog data into the digital form. It involves your three-step sampling, quantization and encoding. Now this was all about the conversions to your digital signals, but there are two other conversion also, digital to analog and analog to analog. So to send the digital data over an analog media, it needs to be converted into analog signal. There can be two cases according to the data formatting. One is band pass. So the filters are used to filter and pass frequencies of interest. A band pass is a band of frequencies which can pass the filter. So basically, there is a band of frequency which can pass through a filter if any frequency is greater than that particular band, which would represent a noise, and we will remove those frequencies. Similarly, another filter is low pass filter. Low pass is a filter that passes low frequency signals. So when digital data is converted into a band pass analog signal, it is called digital to analog conversion. When low pass analog signal is converted into band pass analog signal, it is called as analog to analog conversion. So in case of digital to analog conversion, when data from one computer is sent to the another via some analog carrier, it is first converted into analog signals. Analog signals are modified to reflect the digital data. An analog signal is characterized by its amplitude, frequency and phase. So based upon that, there are three kinds of digital to analog conversions. One is your amplitude shift keying, another is your frequency shift keying, and third one is your phase shift keying. Now for analog to analog conversions, analog signals are modified to represent the analog data. This conversion is also known as your analog modulation. So analog modulation is required when band pass is used. Analog to analog conversion can be done in three ways: amplitude modulation, frequency modulation and phase modulation, which are based upon the characteristics of an analog data. So this was pretty much about your signals and how data communication is done. I hope this is clear to you. Let's meet in the next video and we will be discussing the different aspects of your physical layer. So till then, bye bye, take care.